So guys, we are continuing our lectures on data series and algorithm in Python. So today we are going to discuss about data structure, RAM, memory. So these are the topics we will discuss. First of all, we will discuss how to write a number in bit form. Then we will discuss about RAM and memory in the RAM, how to store data in a RAM, and finally what is the data structure. So first of all, I want you to write 5 and 21 as a bit form. If you don't know, don't worry, we have solution in the next slide, but if you know, please try it. So these are the answer of the 5 and 21 in a 8-bit form. Okay, these 1 and 0 are the bits. Okay, so how 5 is coming, like first of all, these are we start from the right. See, this place is 0, it is called 0 place, it is first place, it is second place, it is third place, it is fourth place, it is fifth place, it is sixth place, and it is seventh place. So in 8-bit there are 7 place. So basically what we do, we write to the power particular place and multiply it with bit form, and we do this for all the bits and then calculate sum. So we see that in this first place we will do 2 की power that place and multiply it with that particular bit. Okay, similarly we can see that for second place 2 raised to the power that particular place and multiply it with bit form. So if you calculate this sum, you will get 5. Similarly for 21 you can see that first we multiply 2 raised to the power 0 into 1, so that we will get 1. Then here we will get 0 ultimately. After here we will get 2 raised to the square into 1, so here sum is up to 5. So this place is third place, so we will get 0 here. So here we will get 2 raised to the power 4 into 1, so 16 plus 4 plus 1, 21. So this is the method to write a number in a bit form. So this is the 8-bit form because we have taken 8 bits. But you can see that the maximum value that can be stored in this 8-bit form is 256. When we when we replace all these bits by 1, that is all bits are 1, you will see that the sum is 256. So what is the limitation of 8-bit? That maximum number that can be stored in 8-bit is 256. So in our computer we have either 32-bit and 64-bit, in 32-bit and 64-bit our memory can hold a very large number. Okay, so see, these are the examples how to write 5 and 21-bit 21 in 32-bit. So you can see these are the answers. So I want to discuss you about CPU, RAM and storage. Okay, so what is storage? Storage is basically memory where data is stored permanently. Means if you close the application, your data will not be lost. Like when you save a file in a computer, it go to the storage and it remains there. Okay, but in a RAM, if you close the application, your data will be lost. Like whenever you write a code and run it, all the variable assigned in that particular code or all the data goes to the RAM, and once you close the program, it got deleted from the RAM. Okay, so what is the use of RAM? So basically why we are using RAM instead of storage? It is because the CPU, the mind of the computer, can read random access memory RAM very fast as compared to the storage. So that's why whenever we run a code in our computer, all the data of that code goes to the random access memory, and from the CPU it accesses the data and run the code. Okay, now we will see how the data is stored in the random access memory. Okay, so this is our random access memory. You can see that it is made up of blocks. These are the blocks, and these blocks, one block is called 1 byte, and these are the addresses of a particular block. Okay, so basically what happens, that this block, in this block data is stored in the form of a bit, that as we have already converted our number 5 and 21 into bits, you can see that this 5 is stored in this form in this memory at the location 0. Okay, but in most of the computers, today's computer, they are mostly 32 bit and 64 bit. So you can see that it will take 4 byte. Okay, this one block is 1 byte, so to make it 32 bit it will take 4 bytes. Okay, so how data will be stored? It will be stored as a 32 bit and it will take 4 bytes. Okay, similarly if the computer is a 64 bit, what it will take? It will take 8 bytes and there will be 64 bits. So in this way data is stored in the memory, and you simply remember that data is nothing, memory is nothing but it is a storage with bytes, and each byte is numbered with this address. Okay, now we will discuss further. So guys, what is data structure? It is basically how the data is stored in the memory. We can reduce the time of our code by using the right type of data structure. So let's see an example. So suppose this is an almirah. Okay, so we consider this almirah as our memory, and we store books in this almirah, so our books are our data. Okay, so what will happen, suppose this almirah is filled by books and you want to take out one book from this almirah. What will happen if the book is in this front end, that is the end that is near to this gate? You can take it out very easily. But suppose if the book is in the rear end, that is the back end, then you have to first replace the books that are in front of this near to this door, and then you will take out this rear end book and then you can use it. But you notice that whenever you if you are using that book frequently and you are placing it in the rear end, whenever you are getting the data, it is taking every time when you are taking out the book, it is taking a long time. Okay, so you should be placing that book in the front end and near to this door, so that the time taken by you to take out the book is less. So similarly, data structure is basically to store the data in a way so that whenever we snatch the data or we use the data, whenever we want to take out the data, it takes less time to take out it from the memory. Okay, to read it from the memory. Basically CPU will read the data from the memory, and what we want that it take less time to read that data from the memory and use it in our algorithm. Okay, so we will discuss about different type of data structure and their uses in particular cases. So first of all we will discuss about the arrays.